totally 4 IO ports. As you all know that IO is nothing but input and output ports. So these IO ports, 4 IO ports, they are inbuilt for the 8051, whereas each port consists of 8 pins. Each port consists of 8 pins. That means 8 plus 8 plus 8 plus 8 or 4 into 8. Totally 32 pins out of 40 pins. 32 pins of 8051 are meant for connecting the input and output devices externally. And all these pins, as 8051 works with 8 bit of data, these pins can also take the input and can send the output of 8-bit size only. And while discussing about the pin description, I have clearly mentioned you that there is a clear-cut difference between port 0 and the remaining ports, port 1, port 2, port 3, they belongs to one structure and port 0 belongs to another structure. I'll tell you what is the difference. There is only one small difference between port 0 and the remaining ports. That particular difference is that port 0 does not contain internal pull-up resistor. Port 0 pins, port 0 pins, they don't contain internal pull-up resistor, whereas coming to the remaining ports, port 1, port 2, port 3, they all have inbuilt pull-up resistors. They all have inbuilt pull-up resistor. What is pull-up resistor and what is its functioning? What will happen if internal pull-up resistor is not there? Those things that we will discuss in today's class. And before moving on to the exact topic, that is nothing but discussion of port 0 and remaining ports, uh, port 0 or port 1 or port 2 or port 3, all of them have 8 pins in each port, and each and every pin has internal structure. Each and every pin has internal structure. So now in today's class we are going to discuss about that particular internal structure. Yeah, see here, this is the internal structure of port 0. Internal structure of port 0 means the pins which comes under port 0, each and every pin internally it will be having this particular circuit. Internally it will be having this particular circuit. This is the structure of one pin of port 0. Remaining pins will also have the same structure. Structure in the sense, this is the internal circuit with which each and every pin of port 0 is associated. So this is how it looks like, and if you observe this, this particular structure, it has totally 3 parts. This entire structure, we can segregate that into 3 parts. These two, this triangle symbol with 3 lines. Here we can see one symbol and here we can see one symbol. So these two together are called as input tri-state buffers. I'm repeating, this particular thing and this one, they are nothing but the tri-state buffers. They are nothing but tri-state buffers. What exactly buffer? Buffer is nothing but whatever the input that you give, the same will be produced as an output. That is the functioning of a buffer. So these two are called as internal tri-state input buffers, this symbol and this symbol. And the next important part in this particular structure is the control logic. Control logic. So this entire thing, here one NOT gate is there, one AND gate and one MUX. So these three things together can be called as control logic. These three things can be called as control logic. And next is nothing but output driver. Output driver, that is nothing but these two transistors together. These two transistors together can be called as output driver. So these are internal tri-state buffers. This we can call it as a control logic, and the last part we can call it as a output driver. And now see, yes, all these pins of each and every port are can act as input pins or they can act as output pins. So now I am particularly talking about the port 0. So now, how to identify whether that particular pin is acting like input pin or whether it is acting like an output pin. So in yesterday's class, while I'm discussing about the pin description, I have clearly mentioned that if one is existing at the port pins, if logic 1 is there at pins of either port 0 or the remaining ports, that indicates that those pins are acting as input pins. If logic 1 is there at the pins of ports, then that indicates that all those pins are acting like input pins. Acting like input pins means they are ready to take the input from the external devices. They are ready to take the input from the external devices. And if 0 is present, at those pins, then in that scenario it will be acting like an output pin. So if 1 is present, it acts like an input pin, and if 0 is present, then it will be acting like an output pin. I told you what is input pin. Input pin means it is ready to accept the data that is coming as an input from the external devices. Then what is meant by output pin? Output pin is nothing but once if any external device sends some information through these particular pins, the processor will do some operation on it. After performing the operation, it will be sending the result. So through whom the external devices will receive that output? Through the output pins. So output pin will carry the data from processor to the external world. Input pin will carry the data from external world to the processor. So that is the difference between input pin and output pin. Input pin accepts the input, output pin sends the output from processor to the external world. And now we will see how to configure this structure as input structure, how to configure this as input and how to configure this structure as output. That we will see in detail. So now see here. Now I am configuring port 0 pin as an input port. So I want to make one of the pin of port 0 as an input pin. So how exactly the internal process will be? So as I told you, if you want to make use of those pins as an input port, there should be a logic 1. See here, ma. Before I explain you how these zeros and ones are coming here, see here we have read latch, internal bus, write to latch and read pin. Let me explain you what are all these. See here this is nothing but a D flip-flop which is acting like a latch. First thing that you need to remember is that these are the buffers. I have explained you already, and here it is a D flip-flop, and here it is not acting like a flip-flop, it will be acting like a latch. What is a latch? Latch is a 1-bit storage device. Latch is 1-bit storage device. That means it can store either 1 or it can store either 0. It can't store both the numbers. So here D flip-flop will be performing that latch operation. And what is the functioning of this D flip-flop? Whatever the input that you are providing to pin D, pin D, same will appear at output. Here D is within this D flip-flop, the thing that you are giving to the D, that is considered as an input, and the output is taken at Q. Input is given to the D pin and output will be taken at Q pin. So here whenever you are providing 1 to D pin, the same one will come as an output. Then what is the difference between the buffer and the D flip-flop? Here for the buffer, nothing is required to take the input as an output. Whatever the input that you are giving, it will be taking it by default, it consider it as an output. But here, to make sure that whatever the input that it is receiving, to make it as an output, the D flip-flop should be enabled by a clock signal. D flip-flop should be enabled by a clock signal. Enabling is nothing but, even though you are providing your input at this particular D pin, if you are not giving the clock signal, then you can't see the output at Q pin. I'm repeating it once again. Even though you are providing your input, one input pin is there to the flip-flop and you have given that input. With that input, if you want to see any output using the D flip-flop, it is not possible unless you provide a clock signal. D flip-flop will start functioning only when it receives the clock signal. So now just assume that, not assumption, we know that if you want to make any pin as an input pin, we need to give the particular pin should carry 1. So whatever the logic I'm saying either logic 1 or logic 0, that should be given at this particular internal bus. The input 1 or 0, that should be given through internal bus. And here to the clock, right to latch, through this particular pin the clock will be provided. And what have we given to latch, whether we have given 1 or whether we have given 0, if you want to know it, then that can be known through this upper buffer. Here we have upper buffer and lower buffer, right? So we have given 1, but still you have a doubt that whether you have given 1 or 0. In between the operation, you just got a doubt that what is the input that you have given, 1 or 0. Then how to know that? Through this upper buffer, whatever the input that you are giving here, the same will come as an output whenever you are enabling the D flip-flop with clock. So whatever the value that is available here, that is nothing but the input. So this will be going as an input to this particular buffer. So from this particular buffer, we can read the values. Read latch means whatever the value that is present within the latch, that can be read using this particular upper buffer. What will be the lower buffer will be doing, that we will know if we move into the internal structure. So I hope as of now it was clear to you. I'll just brief you and I'll move on to the internal values. So to make any pin, any port pin as an input pin, we need to give 1 as an input. We need to give 1 as an input. To whom we should give 1? To the D flip-flop, to the D flip-flop. And through internal bus, we will be giving 1 to the D flip-flop. And in order to activate the D flip-flop, clock should be enabled. So through write to latch, using this particular write to latch pin, you will give your clock. So now input is ready and clock is also enabled. So the same input will come out as an output. Yes, as we have given 1, we are giving 1 because we want to use port 0 as input port. So to use port 0 as input port, 1 should be given. Okay, so I have given 1 and 1 is considered as an output. And when q is equals to 1, then q bar is going to be reverse of that, 0. Okay, and now this 0 is given as an input to mux. Here mux is nothing but multiplexer. I hope you all know what is multiplexer is. Multiplexer is nothing but multi-input single output device. Multiplexer is nothing but multi-input single output device. That means it will be having so many n number of inputs, but it will be providing only one output. So based on what conditions it will provide the output? Based on the control logic, So you just try to understand the mux operation. Here mux is the 2 by 1 mux. 2 by 1 means it will be having 2 inputs and it will be having 1 output. So what are those 2 inputs to this mux? One is the Q bar. Q bar is one input and another input is address or data pin. Another is nothing but address or data pin. So here I want to discuss one thing. Here if you observe port 0, if you look into the pin diagram of port 0, see here port 0 pins, nothing but from 32 to 39, even though they are acting like port 0 pins, they have been multiplexed with address and data lines. Port 0 pins are multiplexed with address and data lines. That is the reason the structure has address and data lines. That means now we need to decide, even though you are configuring that as an input port, now we have to decide whether it is acting as an input device or output device, or those pins are carrying address data. So in order to make sure that it is not carrying any address and it is not carrying any data, the control signal value should be 0. I am repeating once again, as port 0 is multiplexed with address and data lines. That means those pins may carry, they may act as input port or output port. That is the one functioning, and they may also carry the address lines or data lines. But here, as of now, we want to make use that port 0 as an input port. That means you want to connect one particular device to that particular port. That means in that scenario, it should not carry any data and address. So to make sure that port 0 is not carrying any address and data information, the control signal value should be 0. The control signal value should be 0. If control signal value is 0, that indicates the processor that now port 0 is being used for, port 0 pins are being used for IO operation. They can't carry any address and data information. If control signal is 1, then what will happen? We can't make use those pins as IO pins. We have to make use of those pins for address or data information. Okay, so here MUX is having two inputs. One is Q bar and another is address or data. When control logic becomes 0, when control signal becomes 0, whatever the information that is there in this particular address or data line, that will not come to the MUX, because we are controlling that. We are controlling that by giving a value of 0. When control signal value is 0, then MUX will not consider address and data information. It will consider only this particular value. So 0 will be appearing across 0. So if you observe here, I have indicated that with a green line. Here two inputs are there. Among these two, one will be coming as an output. So which one is coming as an output? Q bar is coming as an output. Why Q bar is coming as an output? Because we are giving control signal value as 0. Control signal value is 0 means that indicates that those pins are not carrying any address and data. When they are not carrying any address and data information, here there will be no value. So whatever the value that is available at this particular pin, that will be coming out as out will become 0. And here, if you observe the control logic signal, here we have one AND gate. To this AND gate, one input is control signal whose value is 0. And if you could remember the truth table of AND gate, if any one of the input is 0, then output of AND gate is 0. It is its functioning is similar to multiplication. If any one value is 0, you multiply that with any other value. 0 into anything will give us 0. So in that way, the output of AND gate will be 0. And now this particular transistor has an input of 0, and this transistor also has an input of 0. So when transistors receive 0, they will be turned off. So here this transistor will be in off mode, and this transistor will also be in off mode. The above transistor, it is connected to plus VCC, and the below transistor is connected to ground, because as they have received zeros, this particular terminal cannot be connected to here. In the same way, this terminal cannot be connected here. So what will happen? There will be no connection between these two and these two. So in that scenario, here if someone asks what is the value at this particular position, we can't say it as a 0 and we can't say it as a 1, because it is connected here. This particular point, it is connected in between these two transistors, but these two transistors are in off mode. That means this particular point, it is neither connected to 5 volts and it is neither nor connected to ground. So that particular state, we call it as a high impedance state. We call that particular state. That means whenever we don't know what is the value that appears here, that particular state, we call it as a high impedance state. So whenever there is a high impedance state, what is the next thing? We want to make this port as an input port. That means port has to read some value from external side. But here we have struck up that we don't know what is the value that is appearing here. So what we have to do, as port 0 does not contain any pull-up resistor, we have to connect one pull-up resistor externally. If you can see here, I have represented a dotted resistor. Dotted resistor here indicates that is not inbuilt pull-up resistor. It has been connected externally. So whenever this particular pull-up resistor is connected between this particular point and the 5 volts, what this pull-up resistor will do, here we are not sure whether it is 5 volts or whether it is 0. So what this pull-up resistor will do, this pull-up resistor will pull up the high impedance state to VCC. It pulls up the high impedance state to VCC. That means this particular point will be directly connected to VCC through this particular resistor. Now this connection will not be considered. Now this is not considered because it is in off mode and we have externally connected pull-up resistor. So this point through this particular resistor, it will be connected to VCC. So now the value at this particular point is set to be 1. Why 1? Because here 5 is there. But digital values, we have only zeros and ones. 0 represents 0, any other value. So now here the value at this particular point, soon after connecting the pull-up resistor, as it is pulling up this value to 5, we consider value at this particular point as 1. So as port 0 has received 1, it consider that I have to receive input. So it will be receiving the input from the external world, and whatever the value that it has received, it will send that received input through this lower buffer to the D flip-flop. I'm repeating here. Soon after we introduce the pull-up resistor, the value will become 1. So now port 0 has received 1. When it received 1, it understands that yes, processor is ready to take the inputs. From whom it is ready to take the inputs? From the external world. So it will say to the external world that I am ready to accept your input. So some device has sent the information. It has sent 1. So the same 1 will appear here. It will take it as an input and it will produce the same as an output, and that 1 will be that it has to be processed, right? That means it has to be given to the processor. So that given 1 through this particular lower buffer, it will be given to the D flip-flop. So 1 will reach to the D flip-flop. That is nothing but this is all the internal structure of processor, right? So processor will do its operation and it will send the output. How is it going to send the output? That we will see in the next slide. So this is what all about how port 0 can act as an input port. This is how port 0 can act as an input port. I hope you people understand this. Guys, are